Hello and welcome to Next Tech Genius. Here we dive into the latest advancement in digital technology and programming techniques to help you stay ahead of the curve. Whether you're a beginner looking to start your programming journey or a seasoned professional seeking to expand your skills, this channel is for you. So don't forget to hit the subscribe button and turn on notifications so you never miss a video. Let's get started.
Hello and welcome to this lecture. In this lecture, we shall be looking at what are databases and why use them. A database, also known as schema, is a tool that efficiently stores data and lets you create, read, update, and delete data. The data is actually the information that is stored in the database. For example, your name, age, height, etc. are some data related to you. An image or a file can also be considered as a data. So, database is a systematic collection of data. Databases are modeled to contain information in a table. So, since we've established that a database stores data, is it the only method of storing data? Not at all. There are other methods, such as storing some amount of data in a text file, and this text file can be retrieved and updated when necessary. Another method is using a spreadsheet like Microsoft Excel. A spreadsheet like Excel makes these tasks relatively easy to do by organizing data into rows and columns, making your data easier to access and comprehend. But all of these are not the best option of storing and manipulating data. The most efficient way is by using a database. A database management system, short for DBMS, is actually a collection of programs which enables a user to access the database, manipulate data, and representation of data. It helps a user control access to the database. So, in the next lecture, we are going to be looking at some of the reasons you should prefer a database instead of a spreadsheet. Let's say we have a database for a school called SchoolDB. In the database is a table. Let's call this table student details. Then I'm going to enter some data. You can see that each column has an attribute of the entity I want to store, and each row has the data itself. Like I stated earlier, databases have a wide variety of users, such as a business analyst, marketing analyst, sales analyst, data scientist, software engineers, a web developer, and other IT professionals. Now that we've known what a database is, let's look at some cases why you may need to transition from spreadsheet to databases. A spreadsheet is a computer software that stimulates paper worksheet. It is used to tabulate data and create graphs based on a given data. On the other hand, a database is a collection of related data that can be accessed efficiently. A spreadsheet is meant to handle a small amount of data. Too much data is impractical to handle in spreadsheet as it becomes more difficult for a user to edit it. A database is designed to hold a large amount of data, a lot, compared to a spreadsheet. Relationships are impossible with spreadsheet, while databases are built around relationships to avoid data redundancy. Almost no data privacy in spreadsheet, while there is data privacy in databases. Version control for data and report is not possible in spreadsheet, but version control for data and report operation is possible in databases. So these are some of the reasons you may prefer a database system to spreadsheet. I'll be guiding you on how to set up postgreSQL on your machine. To use Postgre on your machine, you need to install the Postgre database server and a graphical tool to administer and manage the database. and I will be using pgadmin, which is the most popular graphic user interface tool for Postgre. So, to download Postgre on your machine, you need to navigate to www.postgresql.org/download. Then I'm going to select Windows. That's because I'm using a Windows machine. Next, you'll be given two options: the interactive installer by Enterprise DB and the graphical installer by BigSQL. BigSQL currently installs pgadmin tray, which is deprecated. So it's best to choose Enterprise DB, which installs the latest version. If I click to download the installer, I will be presented to desired Postgre versions and different operating systems. So select the latest Postgre version and OS as per your environment. Since I'm working on a 32-bit OS, I'm going to click on this download button and the download will begin. So I'm going to pause the video and let the download finish. So once the download is finished, open up your download folder and you should see the exe file if you're using Windows. Before now, I have downloaded a previous version, so make sure you download and install the latest version. So I will click on the file to begin installation. Click on yes if prompted to allow user account control. Here we are presented with a welcome screen. Click on the next button and here you can change the installation directory if required, else leave it as default and click next. You may also choose to uncheck these components or leave them by default and click next. You can change the data location or leave it as default and click next. Here you are required to enter a password for database super user. I advise you provide a simple password you can always remember. So let's enter 123456 as our password. Leave the port number as default and click next. Next. And here we have our installation summary to review. So let's click on the next button and next to begin the installation. Now I'm going to pause the video and resume when it's almost done. Once the install is complete, you will see the Stack Builder prompt. But for now, I'm going to uncheck it and click Finish. Now we have successfully installed Postgre on our machine, and in the next lecture, we shall be verifying our installation. In the last lecture, we were able to download and install Postgre. So in this lecture, we shall be verifying our installation. To launch Postgre, go to the Start menu and search for pgadmin and then select it. This is going to take some time, so be patient while it initializes the graphical user interface. Great! Here we have the pgadmin interface. So, to actually verify that everything is working, we need to click on the servers icon to expand it. Then click on the next icon again and you should be prompted to enter the super user password set during installation in order to connect to the server. And remember, our password is 123456. So click OK. And when you see the dashboard this way, you should know that everything is working correctly. On the left side of the dashboard, you can see databases. And under the database, I just have one default database, Postgres. And if I expand it, you will see other information about the database. If I click on it and then go to the SQL tab, and here you can see the complete SQL that was used to create this Postgres database. Actually, we don't need all of this to create a database. As you can see, we just need the create database statement followed by the name of the database. However, all of these are optional. So, in the next lecture, we shall start right away creating our very first own database. See you in the next lecture. Hello and welcome to this lecture. In this lecture, we are going to learn how to create a new database in Postgres. Actually, there are two ways of doing this. First is using the PG admin interface, and then the second is using SQL command. Now to do this, using the first method, I will simply right-click on databases and select create database. Then on the pop-up window, we are asked to enter a name for our database. Select the owner of the database, and then you can choose to enter a comment or leave it blank. In my case, I'm going to name my database as student. Then leave Postgres as default. And then I'm going to enter a comment like student database example. Now, once you filled out everything correctly, you can now click on save. And here we have our database created successfully. Now, to create databases using SQL, which is actually the essence of this course, we need to click on Tools, then Query Tool. And right here in the Query Editor, I'm going to type Create Database, followed by the name which we want to call our database. In my case, I will call it Staffs. And then you end every SQL statement with a semicolon, like this. So, the create database is a standard SQL command that creates a database for us based on the specified name. Once we have entered everything correctly, we can now hit on the little icon at the top to execute our command. Wait for some time, and then below we should see a message, queried returned successfully. Now, in order to verify this, I can simply refresh the database listing. And here we have it. Or I can simply use an SQL command. So I'm going to type select date name, which is actually a database name. Then I will use the keyword from pg_database. But before I execute this command, I will prefix __ to convert this to a comment. And this will prevent the create database statement from executing twice. Now click on execute. And here we can see it returned all the database we have, both defaults and the ones we created. In this lecture, we are going to learn how to delete a database in Postgres. Now, I want you to note that the command I will be showing you in a moment is a dangerous command, except you know what you are doing. Once you execute this command, all entries or data associated to a given database will be permanently deleted, and this action cannot be undone. So, you have to use it with caution. First off, we need to select Postgres. Then, go to the Tools menu and select Query Tool to open up the query editor. So, once a database is no longer needed, we can delete it by typing drop database. Then, if exists after the drop database, this is to prevent an error from deleting a non-existing database, and then followed by the name of the database we want to drop. In my case, I want to drop the database we created earlier, which is student. And finally, I'm going to end it with a semicolon. Now hit on execute. And here we have an error that the student database is being accessed by other users. You see this error because the student database still has an active connection. So we need to terminate such connection before we issue drop database command. Now, to terminate the active connection, we need to type the following query. But first, let's turn this into a comment so it does not get executed in the meantime. Now type select followed by pg_terminate _backend. In parentheses, type pg_start_activity. .pid from pg_start_activity, where pg_start_activity dot date name equal to the name of the database that has the active connection, which is student. Now let's hit on execute. And here we go, it returns true. Okay, let's go ahead and issue our drop database now. Great, our database student was deleted successfully. We can verify this by refreshing. And here we go. In this lecture, I'm going to show you how you can create your very first table with Postgres. So, to create a table, you need to follow the syntax or statement. First is the create table clause. And after that, you need to specify the name which you wish to call it. Then, inside of a parenthesis, you can have as many columns as you want. Next to the column names are two attributes. You need to specify the data type and then constraint if any. That means the constraint is optional, but it's recommended to include it in your create table statement. The data type actually determines what type of data that will be stored in a given column. Let's say you have a column called first name. So you would want to make sure it's a string of characters and not an integer. Then, constraints are rules assigned to table columns to determine integrity and accuracy. For example, I can specify not null. This means that this column must not be empty when a user enters his or her information in this table. Now, let's go back to our PG admin. And let's say you want to create a table that will contain records of an employee in a given organization or company. But before we proceed, let's create a new database for this organization or company. Let's say the name of the company is called Lucy Group. So I'm going to type create database. And in my case, I want to name the database as Lucy Group and then end it with a semicolon. Note, you can name your database whatever you like. For me, I just chose to call it after the company's name, Lucy Group. Now, let's execute. And here we have a success message. Let's refresh our databases. And here we go. Okay, it's time we create our very first table on this database. But first, I'm going to show you how you can create a simple table without constraint. So here, I'm just going to comment these ones because we don't need them anymore. Now I'm going to type create table. Then followed by the name of the table I want to create. Let's call it employee. After that is an opening and closing parenthesis. Inside the parenthesis, I will enter our very first column, which is ID. And this is going to be an int data type, short for integer. Next will be first name. Data type will be varchar. And in parentheses, I want it to be a maximum length of 50. I will also do the same for last name. Next is email. And this will be varchar. Next is age. And this will be int or integer. And finally, city of the employee. And I will set this to varchar. Finally, make sure you end your statement with a semicolon. You also notice that each colon is separated by comma, except the end colon. So, if I now go ahead and run this, and now our table has been created successfully. One of the ways we can view this table is by entering select star, which means all, and then from the table name, which is employee, then end it with a semicolon. In other words, I'm saying read all from the table employee. If I run this will return all information about the table. And here you can see the result. The ID column having an integer data type, the first name with a character string, last name, and so on. So, this is how to create a simple table in Postgres without specifying constraints. In the last lecture, we learned how to create a table without constraints. So, specifying constraint is like adding some rules upon table creation so that when a user tries to insert record into this table, it must satisfy these rules. Otherwise, the user's insertion will fail. So, we created this table in the last lecture, so we need to improve on it by specifying constraints. But before we do that, we need to drop this existing table and then create a new one with constraints. So what I'm going to do, I'm going to drop this table and then the name of the table which you want to drop. We want to drop the employee table. And then I'm going to hit on run. And here we go. Our table was dropped successfully. So now we need to improve on this table. So I'm going to uncomment this table. So in the ID column, I'm going to add big serial. And this will increment the ID column whenever a new record is being inserted. So next, I'm going to specify not null, which is actually a constraint, and then a primary key. Then in the first name column, I'm going to specify not null. I will also do the same for last name. For the purpose of this example, I'm going to leave the email column because it's not every user that has an email. I'll also leave for gender, and then for the age, I'm going to specify not null. I'll also do the same for city. So now we can execute this query. And the query was returned successfully. Let's comment this and then let's view our table by typing select. Select all from the employee table. And then hit on execute. And here we go. And now our table has been improved upon. We have our first name, character varying, last name, character varying, email, gender, age, and city. Thanks for watching and see you in the next lecture. So far, we have created a table called employee, and we can see that this table have no record for now. The table is empty. The ID column, first name, last name, email, gender, age, and city, they are all empty. So we are going to learn how to insert record into this table called employee. So I'm going to remove all of this, and then to insert record we need to use the insert into clause. So I'm going to say insert into followed by the table we want to insert into. So in this case, we want to insert into employee. After that, you specify a parenthesis And inside the parentheses, we need to specify the column which you want to insert into. So here you can see we have the first column, which is ID, first name and last name. I'm going to specify first name. I don't need to specify this because this will always auto increment for us whenever a new record is being inserted. So I'm going to specify this, and this. So first name separated by a comma, and then I want to specify last name, comma, email, comma, gender, comma, age, comma, and then city. You notice that the last column does not have a comma. So we have our first name, we have our last name, we have the email, we have the gender, the age, and then the city. Next is the values. And then we need to specify a parenthesis again. And inside the parenthesis, we need to enter the values which we want to get inserted into this table. So within a quote, insert a value for the first name. Let's say Mike, comma, and then the surname or the last name is going to be Muro, comma, and then the email will be mike@gmail.com, a comma, and then this is going to be a male, and then the age is going to be 30, and the city in quote is Berlin. And finally, you end it with a semicolon. So if I execute this, and here it says query returned successfully. So I'm going to comment this, and then let's view our table by simply saying select all from the employee, and then if I run, and here we have it. Our first record has been inserted successfully. We have Mike, the last name as Muro, Mike@Gmail, male, the age as 30, and Berlin. You also notice that the ID column has been incremented by 1. What happens if we try to insert this again? So let's uncomment, and let's insert this one more time, and you can see that the ID column has been incremented by 2 for the same record. So if we run this one more time, you see that the ID column has been incremented to 3. But what happens if we try removing the first name? And you can see that we got into an error. Insert has more expression than target columns. That's because the insert statement have more values than the column. We have 1, 2, 3, 4, 5, 6. And then the columns we specify is just 1, 2, 3, 4, 5. So 1 is missing. So we make sure that our column names are in accordance with the values we want to insert. So now let's make some changes and insert another employee into this table. So let's say the first name is Nelson, and then the last name will be John, and then the email will be John, and then let's change the city to Austin. If I hit run, and we can see that the ID column has now been incremented to 4, and here we have our last record. This is actually part 2 of our insert into statement. In the last lecture, we were able to establish that the number of columns must be equal to the number of values. But if you do remember, when we created our employee, we stated that the first name must not be null, the last name column must not be null, the email can be null, the gender can be null, but age and city must not be null. So since we specify that the first name must not be null, let's remove the first name, and then let's also experiment by removing first name. Now if we hit on execute, and here you can see that we got an error. Null value in colon first name violates not null constraint. So we can see that the first name must not be null. So if we go back, and now if we run this query, and we can see that our query returns successfully. But what if we experiment by removing the gender, which we specified that it can be null? So if we hit on execute, and we can see that the query went successfully, but the gender is null. So Nelson at ID 6 has no gender, but age, city, email, last name, and first name. So this is just to show you how table constraints behaves. In the last lecture, we were able to insert some records into our employee table. So we need more records into this table, like 1,000 records, so we can play around and exemplify things. So in this section, I'm going to provide a file so you can copy these records and then insert it into the employee table. I have the record already in my computer. So I'm going to navigate to my local disk. And then here is the employee. It's actually an SQL file. So I'm going to right click. You can open it with any text editor of your choice. But since I have Sublime, I'm going to open it with Sublime. And here we have it. It's about 1,000 records. I actually scroll down and you can see that. So this data was actually generated from the Mokaro website. You can go ahead and visit mokaro.com and you will be landed on this page where you can choose your field name or your column name. We have ID, first name, last name, email, gender, and all of that. You can also add another field of your choice. And then you select your type. This is like the data type. And then Mokaro allows you to generate up to 1,000 rows free. They do have a premium version, but at first they allow you to generate 1,000 rows. And then you can choose your format. I recommend you choose SQL, and then next you can name your table. You can also choose to include the create table statement. And once you're done, you can now download your data. So, since we have our data already downloaded and you have it on this section, so what I'm going to do, I'm going to copy all of this, and then I'm going to go back to our query editor, and then going to remove this and then paste our records. And here we have it. You can see that it's about 1000 records. Now I'm going to hit on execute. But before that, you notice that we have the first name, last name, email, gender, age, and city. The ID is not included. That's because the ID is big serial, so which is going to auto increment whenever a new record is being inserted. So if I hit on execute, and here we have query returned successfully. So now I'm going to click on this icon and then click on clear query window. Then yes. Then we are going to view our table simply by typing select all from employee table. Let's hit on execute. And here we go. We have all of that being inserted. We can see we have about 1006. That's because we have a previous record being inserted. So now that we have inserted more record into our table, so in the next lecture, we are going to learn more on the select keyword. In this lecture, we are going to learn how to use the basic select statement to query records from a table. Though we have been using the select statement before now to retrieve an entire table. For example, if I want to retrieve all records in the employee table, I can simply type select star, which is all, from employee, from the employee table. And then if I hit on execute, and this returns all records in the employees table. What if we want to select or retrieve records only from the first name column? So I can simply say select, then the name of the column we want to retrieve. So I want to retrieve from the first column. So I'm going to say first underscore name, and then from the employee table. If I execute, and here we go, we have all the records or data only from the first name column. I can also retrieve the first name and then the last name. So I'm going to say select first name. Because I want to retrieve more than one column, I'm going to separate the first column by a comma, and then I want to retrieve from the last name. From the employee table. If I hit on execute, and here we go, we have the first name and then the last name column. And lastly, if I also want to retrieve both the first name, last name, and email, I can simply say select first name, comma, and then last name, comma, and then email. So from employee table. If I hit on execute, oops, we made a mistake. This should be R, first name. So now let's execute. And here we go. It returns all records in the first name, last name, and email column. So this is just a basic example of how to select or retrieve data from a given table. In this lecture, you will learn how to sort result set returned from a select query using the order by clause. We've seen that whenever we query records or data from a table, Postgres returns these records in the order that they were originally entered. So, there are times we may want to sort this result set either in ascending or descending order. For example, if I want to retrieve records from the employee and then I want to order by last name, I can simply type select star from employee order by last name. If I run this, and here it returns all records ordered by last name. You can see that we have the A's, and if I scroll down, you can see that we have the B's, all ordered in ascending order. Note that records are returned in ascending order by default, so you can choose to include or omit an ascending order in a statement. For example, I can say order by ascending ASC, and this is a short version of ascending. If I execute this, you can see that it returned the same result. So we can choose to omit the ascending or include it. What if we want to order by descending? So I can simply say select star from employee and then order by last name, but this time in a descending order. So I'm going to type the short version of descending like this, DESC. And then if we run this, and you can see that it returns all records in descending order. We can see that the Z and then down to the A's. We can also select more than one column and then order by a given column. For example, I can say select last name, comma, gender from employee, and then I want to order by last name, but in a descending order. So I'm going to type the short version of descending. Now if I execute this, and here we have it. So it returns only the last name and gender, and then ordered by last name. So I'm ordering by last name. You can see that the last name is in descending order, starting from Z to the last, which is A. We can also include the city by entering a comma and then the city colon. If I execute, and here we go, all ordered by the last name in descending order. So this is how to use the order by clause in Postgres. In this lecture, we are going to learn how to use the distinct clause together with select to remove duplicate records from a result set returned. For example, if I want to retrieve every age of an employee in the employees table and then order by age, I will simply type select age from employee, and then I want to order by age. If I execute this, and you can see the order at which every employee's age is being returned. Now you can see we have 15, 15, and if I scroll down, you can see a lot of duplicate values. So to get rid of this duplicate, we can use the distinct clause simply by typing select distinct and then the age colon from employee table, and then I want to order by age. If I execute this statement, and here you can see that it returns every age of an employee without duplicate values. So you see we have 15, 16, 17, 18, 19, 20, 21, and all the ages of an employee down to 100. So this is how to use distinct clause to remove duplicate records from a result set returned. In this lecture, we are going to learn how to use the where clause to filter rows of data returned from a select statement. Basically, we have been using the select statement to query data or record from a table. But what if you want to query just a specific row from a table? So we need a condition to filter that row using the where clause. As usual, if we want to retrieve all records from the employee table, we can simply type select star from employee, and if we run this, it should return every record from the employee table, and here we have it. Now if I want to retrieve records where the gender is just females and not male, I can simply type select star from employee, and then I'm going to use the where clause where gender is equal to, and then in quotes I'm going to specify the value of the condition. So the value of the condition is a male, and then I will end it with a semicolon. So in other words, I'm saying retrieve all records where the gender is equal to male. So if I execute this, oops, typo, O is missing. So if we run this, and here we can see that it returns all records where gender is equal to male. So you can see that all from the beginning to the end, it must satisfy this condition where the gender is equal to male. We can also specify where the gender is equal to female. If we run this, and here it retrieves all records where the gender is equal to female. I can also retrieve all records where the employee's age is 50 years. So I'll simply say select star from employee, and then where age is equal to, in quote, the value of 50, and then I'm going to end it with a semicolon. Now if I execute this, and here we go, so it returns all data or records where the employee's age is 50. You can see that we just have about 10 records or 10 employees where the age is 50 years. So this is how to use the where clause in Postgres. In this section, we are going to look at logical operator in Postgres. There are 3 of them: the AND, OR, and NOT operator. They are mostly used to join conditions in SQL statements, especially in the where clause and having clause. So let's look at the AND and OR conjunctive operators. For example, if I want to retrieve all records from the employees table where age equal to 50 years, I can simply type select star from employee where the age is equal to, in quotes, 50 years. If I run this, and it will retrieve all records where the age is equal to 50, and we just have about 10 employees. Now I can include the AND operator just after the age to be used in conjunction with the where clause. So I'm going to say and gender is equal to, in quote, male. In other words, I'm simply saying that retrieve all records where the age is equal to 50 years and as well as the gender is equal to male. So these 2 conditions must be met in order for this query to run successfully or to return our records. So if I execute this, and you can see that we just have only 2 records or 2 employees where the gender is male and then their age is 50. So this is how to use the AND in conjunction with where clause. I can also specify where gender is equal to female. If we run this, and here we go. So we have more records or more employees where the gender are females and then their ages are 50 years. So we have about 8 employees. I can also retrieve all records where the employee's age is 110 or city is Berlin. So I'll simply comment this, and then I'm going to say select star from employee where age is equal to 110, and then I'm going to specify the OR operator, or city is equal to, in quotes, Berlin. And then I'm going to end it with a semicolon. So I'm simply saying retrieve all records where the age is equal to 110 or city is equal to Berlin. So one of these conditions must be met. Is either this returns true or the city returns true. So if we actually execute this, and here we can see that it returns records where the age is 110 or the city is Berlin. But looking at these records, you can see that the age is not 110. So since this condition is not true, then it checks the next condition. So looking at the city, cities are Berlin. So it returns the condition. So it's either this condition is true or it checks the next condition and then returns all records. I can also say where the city is equal to New York. Now if I execute this, and then you can see we just have one record or one employee where the city is equal to New York. We can also specify more than one city in a given statement. For example, I can simply say select all from employee where gender is equal to female, and then in parentheses I can list the cities. So I will simply say city equal to Berlin or city equal to New York. And then I'm going to end it with a semicolon. If we run this, and here it returns to employee where the cities are Berlin or New York. So this is how to check for multiple cities or colon in a given statement. And let's try for male. If we run this, and we have two employees where the gender is true, but it only returns where the city is equal to Berlin. So this is how to use the AND or conjunctive operators.
In this lecture, we are going to learn how to use the IN operator in Postgres to check against a list of values. If you remember in the previous lectures, where we use the conjunctives operator such as OR. For example, if I want to retrieve all records where the employee city is equal to Phoenix, or city is equal to Austin, or city is equal to Berlin. So I can simply do something like this. Select all from employee where city is equal to, in quotes, phonics, or city is equal to Austin, or city is equal to Berlin. If I run this query, and here we can see that it retrieves all records where cities are equal to Berlin or phonics. So we have an alternative way of doing this, that is using the in operator. So instead of writing it this way, I can simply say select all from employee where city, and then I'm going to use the in operator followed by a parenthesis, and in between the parentheses I can now list the cities which I want to retrieve. So the first one on the list we have is phonics. Oops, we need to include a quote. So we have phonics, comma, next we have Austin, comma, and we have Berlin. Finally, you end it with a semicolon. Now if I run this query, I can see that we have the same result. It retrieves all records where cities are Berlin, Austin, or phonics. So this is where the in operator comes in handy and simplifies your query instead of this. Thank you for watching, and in the next lecture we shall be looking at the between operator. The between operator helps us to retrieve values within a range, and it can be used with a select, update, insert, and delete statement. I'm going to erase all of this. I want to retrieve all records where the employee's age is between 20 and 25. So I will select all from employee where age, and then the between keyword, and then I want to retrieve age between 20 and the age 25. So if I execute this query, and here we have it, we can see all employees where their ages ranges between 21 and 25. In this lecture, we are going to learn how we can divide roles into groups using the group by clause. But before that, we are going to create a new product table. Here I have an SQL file which I opened with a text editor. Feel free to open it with any editor of your choice. So I'm going to include this file in this section so you can download and play around with it. So here I have about 1,000 records. If I actually scroll down, and you can see that I have about 1,000 of them. And before the insert statement, here I have a create table statement, and I'm going to create a product table. And after the create table statement is the insert statement that will insert 1,000 records into our product table. So now what I'm going to do is I'm going to copy all of this. And I'm going to open up our query tool. Then inside the query editor, I'm going to paste all that I have copied. And here we have it. I'll hit on run. And here we have a success message that query returned successfully. Next, I'm going to clear the query window. Now let's check if this table really exists in our database. So I'm going to select star from product. So now I'm going to run the query. And here we have it. We have the first column as ID. We have the second column as items, color, manufacture date, and then the price. If I scroll down, and you can see that we have about 1,000 records of it. So now that we have imported our new table, in the next lecture, we are going to demonstrate on how to use the group by clause. In this lecture, we are going to learn how we can divide rows into groups using the group by clause. In the last lecture, we actually imported a new product table. And now I'm going to demonstrate how we can use the group by clause. So let's get started. First of all, I'm going to retrieve all the rows or all records in the product table. So I'm going to select star from product. And now if I run this query, and here we have all records from the product table. That's about 1,000 records. So now I want to group by. So I'm going to comment this. So now we can see that we have the ID column, items column, the color, manufacture date, and price. So what I want to do is that I want to group the manufacture date column. So I will simply say select manufacture date from product, and then I'm going to say group by the manufacture date also. So now I can simply run the query. And here we have it. You notice that if I scroll downward, we just have 45 rows. So what the group by clause does is that it removes duplicate records from our table. So you can see that out of the 1,000 records we have, the group by clause just retrieved about 45 of them. So to actually confirm this, if there were duplicates, I can simply say select manufacture date from product, where manufacture date is equal to 2010 in quotes. So if I run this, you can see that we have 2010 many times. So you can see that we have about 46 records where the manufacture date is equal to 2010. So you can see that just by running this, it divides rows into groups. We can also apply some aggregate functions like sum, count, and all of that with the group by clause. For example, I'll retrieve all record from manufacture date followed by an aggregate function, and in this case I want to use the count. So I will say count followed by parentheses, and inside the parentheses I want to count all from product table. Then group by manufacture date. If I run this query, and here we can see all record, and here you can see the manufacture date colon and then the count, showing that 2010 appears 7 times, 1983 appears 2 times, and 1994 appears 28 times, which means that we have 28 products manufactured in 1994. We have 2 products manufactured in 1983, and so on. But you notice that they are not properly in order, so we can apply the order by clause. So after the group by clause, I can simply say order by manufacture date. So if I run this query one more time, and you can see that they are now in order. So here we have 1955, 1959, 1960, 62, 63, and so on in ascending order. So this is how to use the group by clause in Postgres. In this lecture, we are going to be considering some aggregate functions in Postgres. So the first one we are going to talk about is a max function. So I want to find out the maximum price from the product table. So I'm going to wipe all of this, and then I'm going to select, followed by the function. And now I want to find out the maximum price using the max function like this. And this is what we call the function in Postgres. So inside the parentheses, I'm going to specify the colon which I want to apply the max function. So I'm going to enter the price from the product table. If I run this, and here we have it. And here we have about $9,994. Note, the price colon is not actually in the money format. I can also find out the minimum price. So I'm going to copy this one more time. And then here, I want to find out the minimum price. So using the min function. If I run this, I can see that the minimum price or value is just $1,000. We also have the sum function. So I'm going to change this to sum, and this will retrieve the sum of the total price. So if I run this, and here we have it. I can also retrieve other fields. For example, I'm going to say select, and I want to retrieve the items column, and then the sum of the price column from the product table. And after that, I can apply the group by clause, just like I stated in the previous video. So I want to group by items. So I will simply say group by items. If I run this, and here we can see that all items are grouped by their sum. We also have the average function, which calculates the average of a given column. So I'm going to say average, short for AVG. If I run this, and here we can see the average of this. I want you to notice that these values or prices are not in real world money format. So for the purpose of this lecture, if you are using the Mokaro platform to generate 1,000 records to be used for your SQL lessons, you want to make sure you select the money type so that if we say $50, it should be in this format and not this. So I can also apply the round function. So I will say round, and inside the parentheses, I want to round the average price. So if I run this, and here we can see the results. So this is how simple it is to use aggregate function in Postgres.
Thank you for watching this video. I hope you found it informative and useful. If you did, please give it a thumbs up, leave a comment below, and consider subscribing to the channel for more content on digital technology and programming skills. Stay curious, and I will see you in the next video.